Also, I know that CASA doesn't have Cal2 tutors. I guess they don't have. So if you need any help, just let me know. Okay. If you think you cannot meet me on the scheduled lab timings, just email me your time and I will check my schedule. If I'm free, we can meet face to face or maybe on Zoom, and then we can solve your issues. Okay, let's get started with lab 5. Now you can see that we have 14 questions. Okay, and lab 5 is called techniques of integration. So the meaning is you have 14 questions. Now you're supposed to use the methods, whatever you have learned in the integration chapter. You can use all those methods like U substitution, integration by parts, tabular integration, right? So you, or direct integration. So you have so many options to do. Depending on the problem, you have to think what to choose, and then you can use the method. For example, question number 1, you can use integration by parts, but the problem is these two are recursive function, right? So if you integrate secant, you will get another trigonometric function. If you integrate the trigonometric functions, again you will get back the trigonometric. So it's like recursive function. So integration by parts might not be a good idea for this type of problem, right?
Testing
So
one
what
two.
can you do?
Testing. Testing. Testing.
Think have to be. Okay, so what can you do is, so what can you do? So sorry, where was I? Yeah, integration by parts. So yes, one more option is trigonometric identities. Very good. So that you can use that, or the best method I can say is U substitution. You just have to take U as some function, then do the differentiation, apply it to the integral, right? So most of the problem can be done using U substitution. Now, among these 14, I'll be doing 3 problems. Okay, might not be a same problem, but I don't want to do the same problem because while I was grading your assignments, most of the students they just wrote the problems which I did in the lab. It's like copy paste. So I don't want that to happen. I want students to understand the method. So I am just taking an example similar to the lab problem, and I will show you how to apply the method. And then you can use the same procedure and do the rest of the questions. Okay, sounds good? Fine. So let's get started. We have 14 questions here, and okay, lab 5. Integration techniques. Okay, so first example, all these are example problems, okay? Remember, these are not the same exact question from your lab manual. These are just the example problems similar to your lab manual. Okay, fine. So let me start with the last problem. Integration of sine of theta divided by cos to the power of 5 theta into d theta. Okay. So this is similar to problem number 14 in lab manual. The only difference is in the power. Okay, fine. So I will go with U substitution here. I cannot apply the product rule, right? So I'll go with the U substitution. So U equal to cos of theta. Remember, you can also take it as sine of theta, then the derivative is cos. So it has to be like you have to cancel the numerator and the denominator. So you have to take such a type of function as U, okay? So that it will simplify your integration. Now du by d theta will be negative sine of theta, right? Then what is d theta? D theta will be negative du by sine of theta, right? Now I'm going to plug all these functions here in the integral. I'll keep sine of theta as it is, divided by cos of theta is u, but we have to the power of 5, so u to the power of 5 into d theta. Okay. Integration. Oops, I have what is called as d theta. So d theta will be du divided by sine of theta. And I can cancel sine of theta in the numerator and in the denominator. So I will get, keeping negative outside, I will get 1 by u to the power of 5 into du, right? Okay. I will pause here. Can somebody tell me the final answer? It is quite easy. You just have to apply the power rule. Hmm. I got an answer that is, okay, negative 1 by 4 x to the power of, sorry, u to the power of negative 4. Okay. The answer which I got from Hannawink, that's right. The first answer which you gave me was correct. So, Joseph, thank you for the answer. Okay, now negative, I'll keep negative outside. Now remember, let me write like this. So remember, 1 by u to the power of 5 can also be written as u to the power of negative 5 plus c. That's right? Integration of u to the power of negative 5 du. Now applying the power rule, you will get negative 1 by 4 u to the power of negative 4, or I can take it as u to the power of 4 plus c, right? Now the final answer will be 1 divided by 4, u is cos, so cos to the power of 4 by theta plus c. Okay, I can still simplify. Now, using the reciprocal identity, Can somebody tell me what is the reciprocal of cos theta? What is the reciprocal of cos theta? Very good. Secant, right? So you can simplify further and write it as 1 by 4 secant to the power of 4 theta plus c. Okay. I'll give you a minute to just take a note of it. You can keep it as it is. Like this is also the answer for the integral, but you can still further simplify and just take it as secant to the power of theta. This is just a simplification and it's optional. I mean, you don't have to do it literally, but that is just like a ultimate simplification. Now you can simplify, you cannot simplify this further. So that's the reason I have taken cos as in terms of secant. And one more thing is if you want to say find the values, or if you have a limit, then applying limit for the fractions is difficult. So it is always better to have or apply limits for the numerator, just a numerator or for a number, right? Solving fractions will be quite difficult. Okay. I will move on to the next problem. Um, so let me do this problem. This is example 2, 1 divided by x times cos of ln of x into dx integral 1 1 to 2. Let's take from 1 and 2. Okay. Now I'll be changing the limits in a while, but now this problem will be similar to your problem number of your lab manual. Okay. Now we know that the reciprocal of 1 by cos theta is secant theta, right? Now can somebody tell me which problem will this be in your lab manual? It is similar to which problem? Let me not write the limits. Take a close look at your lab manual and yes, right. Very good. So this is similar to question number 3. How? Remember, you can always write this as 1 over x secant ln of x. Okay. So this problem which I'm doing is similar to your problem number 3. Only difference is I think you have a square here and limits. I think it is pi by 4 if I'm not wrong. So these are the limits you have. So this is question number 3. Now this problem is similar to this problem. Okay, fine. So let's see how to solve this. Now I will apply limits here. 1 e to the power of pi by 3. Okay, now again, I'll be using u substitution, u equal to ln of x du by dx will be 1 over x into dx. Okay, now I can write from here. So I can write dx as x into du. Okay, now applying this in the integral from 1, okay, from 1 to e to the power of pi by 3, 1 divided by x into cos of u into dx was x into du. I'll write it here, x into du. So the numerator and denominator is cancelled. Now this is equal to 1 e to the power of pi by 3, 1 by cos of u into du. Okay. Now, do you think it is correct? Do you think whatever I did till here is right? Or do you find any mistake here? If yes, then you have to tell me what is that. Okay, I will give you hint here. Okay, I got some answer. Exactly right. Very good. So remember, whenever we have a u substitution and we have limits, you have to change the limits as well. Okay, because the limits whichever is given here in the problem is for the variable x, not for u. So when you are converting x in terms of u, then you have to change the limits as well. Okay, so let me take x equal to 1 because that is given in your problem, and x equal to e power pi by 3. Okay, now we have considered u as ln of x, right? So what is log of 1 or ln of 1? Ln of 1. Okay, I didn't get any answer. So ln of 1 is 0, right? Okay, now when x equal to e to the power of pi by 3, what do you think will be u? So this is like this. So x equal to e to the power of, or I will take x equal to 1. So x is equal to 1. Now u is equal to ln of x, right? So ln of 1. So ln of 1 is 0. That's the first limit or the lower limit of u. Now when x equal to e to the power of pi by 3, u is equal to ln of e to the power of pi by 3. Agree? Now, what is the answer? Very good. So it is just pi by 3. How? Whenever we have logarithmic function and exponential function as a product, they two get cancelled. Okay, that's because exponential function is nothing but anti-log. Got it? So these two get cancelled and we are left out with pi by 3. Write that here, pi by 3, and I will erase this. Okay. Now applying the same knowledge here, changing the limits from 0 to pi by 3. So this is 0 to pi by 3, 1 by cos of u into du. Okay. Fine. So next step is integration of 1 over cos of u. Okay. So now instead of integrating 1 over cos of u, I mean, that's we don't have any standard formula, right? So what can we do? We can convert that to secant of u because that's a reciprocal. So this is from 0 to pi by 3. Now you have to convert secant of u, or you have to find the integral of secant of u. So integral of secant of u, the formula is log of secant of u plus tan of u from 0 to pi by 3. If you don't know how I get the, how I got this formula, just let me know. I can show you these steps. So do you know how I got this formula? If not, just let me know. I can show you the steps. I guess you have done this in the previous lab, if I'm not wrong. Okay, so I will assume that you know how to integrate secant of u. Now proceeding to the next step, we just have to apply the limits, right? So this is ln of secant pi by 3. What is secant pi by 3? So secant pi by 3 is 2 plus tan pi by 3 is square root of 3. Okay, upper limit minus ln of secant of 0. Secant of 0 is 1 plus tan of 0 is 1. Sorry, 0. Okay, secant of 0 is 1 and tan of 0 is 0. Got it? Now, this will be ln of 1, right? So ln of 1 is 0. So what is the left out term? Ln of 2 plus square root of 3. Now, should I use plus c here? No. Okay. If you have a definite integral, you're not going to use plus c. Right? So this will be the final answer. Now, if you don't like to change the limits like I did here, if you have some say some large functions and you don't like or you're not comfortable finding the limits, you can still use the same limit. But remember, before you apply the limits here in place of u, you have to convert u in terms of x. Okay, substitute back what is u and then you can apply the limits. Okay, you can do in that way as well. Okay, so I'll just give you a minute to write down. Okay. Moving on to the last problem. Okay, so this is not example, but this is problem 5 in your lab manual. Okay, this is exactly the same problem which I took it from your lab manual. So the problem 5 is integral 1 divided by x square square root of x square negative 1 into dx. Okay, I will not solve this completely. I will do until the second last step, and I will leave the final step to you. Okay, now let's see how to do this. Remember, before I take this problem, I want to give you some inverse trigonometric values or formulas. Whenever you take a derivative of sine inverse of x, the answer is 1 divided by x square minus 1. 1 minus x square. Okay, and the same thing when you take derivative of cos inverse of x, it is negative 1 minus x square. Now when we have secant inverse of x, 1 divided by x into x square minus 1. And then when we have the secant inverse, the derivative is negative 1 x into square root of x square minus 1. Okay, remember these formulas. Okay, now my question is, what should I use for u? What should I take u as? That's one option. Next. Yeah, right. But not secant x, just secant inverse x. So you have to consider u as secant inverse of x. Now you can do this, or else yes, x will be considered as algebraic. So anything in terms of x. So if you have x, x square, x cube, whatever it is, these are all the algebraic. Okay. Now u equal to secant inverse of x, or I can take x as secant of u, right? I mean, both are same. Both are same. Now, the reason I'm taking in this way is when I take a derivative, when I take du by dx, or what will I get? I get 1 x to the x into x square minus 1, right? I get back the same thing here. But remember, I cannot cancel these two terms. The reason is I have x here and I do not have, I have x square here and I have x here, right? Now, when I just plug this 1 into the integral, the left out term will be 1 over x. And this is not in terms of u, right? Then I will not be able to integrate. And that's the reason I'm not taking derivative of u. Instead, I will take derivative of x. Okay. Now, the derivative of secant x is, or secant u is, okay. It's working now. So derivative of secant u is secant x or secant u tan u. Now, so here dx is secant u tan u into du. Okay. Now, Do you have questions till now? If not, okay, if not, I will move on. Now, integral, I took x as secant of u, so u is secant inverse of x, right? So 1 divided by secant square of u square root of secant square of u minus 1 into dx. So I will write dx here on the numerator, that is secant u tan u into du. Okay, now I have an identity that I can use here. So secant square u minus 1 is equal to what? Remember, I think in lab 4 or 3, you had a hint given in the problem. Exactly, it is tan square x, tan square of u. Okay, I'm going to use the same thing here, but remember we have square root of secant square of u minus 1, right? So I have to apply a square root on both the sides. Then this is to the power of 2, and this is half or the square root. These two get cancelled. These two are cancelled. Then the leftover is tan of u. Okay. Now, integral secant of u into tan u divided by secant square u square root of secant square u minus 1 was tan of u into du equal to what? Remember this secant u here and 1 here, they get cancelled, and the leftover is 1 divided by secant of u du. Now the reciprocal of secant of u is what? Right. So this is cos of u into du. Instead of doing the integration of a fraction, it's better to integrate the whole term, right? So and that's the reason I converted secant u to cos of u. So integration of cos of u is sine of u, and I'm using plus c here. That's because we have indefinite integral. Now this is not the final answer, because you have to substitute back what is u, right? Now that task I will leave it to you, because it is not so easy. It might be. So remember, sine u can be written as sine of what was u here, secant inverse of x, right? Now you have to simplify such that you get only x terms in the final answer. Now sine of secant inverse of x plus c, right? That's what you will simplify to, because u is secant inverse of x. Now this is not the final answer. You will get one more final answer when you plug in what is secant inverse of x. Okay, when you simplify this, you will get a final expression, and I need that expression. So that will be your final answer. So I will leave that final step to you. So this will complete lab 5. I have completed 3 problems, and remember, I did only example problems similar to your lab manual. You don't have to do those problems, okay? but you have to do all the problems given in your lab manual. Now, the question is, should I also do this in the MATLAB? Yes. And you must also upload the MATLAB file as a PDF along with the hand calculations like you used to do in the previous labs. So you have to do all the problems in the lab manual, but the problems which I did here, I mean, this exact problem as an example, these are just the extra problems. So, it, I mean, you don't have to write this, but if you want, you can. You don't have to include this in your assignment, but if you like to write it down, you can. But remember, you have to complete all the problems, all 14 problems uh, as the assignment 5. Okay, and next step is Matlab code. Now, I don't want to get into that because that's what we have been doing from previous labs, right? So you just have to define what is X, that is symbolic expression X, and then you are going to enter the function, integrating function, and then you integrate the function with respect to X using int, right? So those 3 steps, you have to do it in the MATLAB, and I need the MATLAB file as a PDF along with the hand calculations, and hand calculations have to include all the 14 problems of your lab manual. And remember, whenever you scan and upload, after uploading, check your document. Because some of the students might have scanned and uploaded only one image, and that would marked as incomplete, then I have to grade only those problems and you might not get a full grade. So whenever you upload, just make sure that you have uploaded the right document. Okay. Right. So I will stop here. So this will complete lab number 5, and I will see you next week. Now remember, I told you that if you need any help regarding lab, I will be happy to help you. So if you are comfortable coming to the class, you can. If not, that's okay. You can attend through online. And if you have questions on the lecture, okay, you have a question on lab. Sure. So I will take that question at the end of the meeting. Now, so if you have any difficulties solving problems like or the concepts you have not understood in your lecture section, I can help on that as well, but not the assignment, but I will try to make you understand the concepts, not in the lab timing, but if you want, I just email me and I can help you with that. Okay. So I will stop the screen share here and the recording.